Yeah, and this lecture will talk about the normal approximation to the binomial distribution, and this works well if n is large, which means np greater or equal to 5 and n times 1p or nq greater or equal to 5. And we can make improvements by using the correction factors. So I want to explain this through an example. But first, let me graphically show you what that means. So I go to the tablet. Oh, where are we now? So if I have, suppose this is my binomial distribution where I have, these are binomial probabilities. So to do the normal approximation, if this was large, it works better. It's basically, I would put a box around each one of them, and if you notice this box, so if I want to compute this probability, I go half a point to the left and half a point to the right, and that's how I create my box. So the box represents the area, is the same as the probability of the binomial distribution. And then once I get that, now I look at it, I have something that's continuous, and the binomial looks very much like the normal distribution. So if I fit a normal distribution here, that's how I compute my probabilities. So if I want this probability, I would just go 1 point to the left, 1 to the right, and find this area under the normal curve. If I want the probability of from this point on, I just go 1 point to the left, and I want to find this whole area under the curve. And of course this works well, as we said, when these two conditions are satisfied, np and n times 1 minus p both are greater or equal to 5. So let's look at this. X be the number of times a fair coin flipped 40 times lands heads. So a fair coin, which means the probability of heads is 0.5. I want to find out what's the probability that x equal 20. And the second part, I want to find out what's the probability x between 10 and 20 using the normal approximation. So first we check np is 20, and np times and n times 1 minus p would be 20. So I have this condition is satisfied. np times 1 minus p is 10, so that's my variance. So my mean is 20 and my variance is 10. So my standard deviation is square root of 10. So I want here the probability of x equal 20. We rewrite this and differ slightly. So I want here p of x, which is my binomial x now, equal 20. And graphically, so I have this graph here, I have the 19 here, the 20 here, and say the 21 here. So these are my binomial probabilities. So to find the approximation to the binomial, to the normal, I go half a point here, and I go half a point here. So I want to find this area, which would be in this case equal p of, that x, now the normal is between 19.5 and 20.5. So we have, this is called the correction factor, going half a point to the left on this side and half a point to the right on the other side. And that's it. Now all I want to do is use my normal distribution. So I want the z-score of this and the z-score of this. So this would be p of z between this value here and this value here, which are given here. So that's my x between 19.5 and 20.5. So to get the z-score of 19.5, I subtract the mean, which is 20, and divide by the standard deviation, which is the square root of 10 here. Same thing on this side, 20.5 minus 20 over square root of 10. And this gives me z, this gives me negative 0.16, this gives me 0.16. And now I go to the z table. Let's see. So now I graph, as we said before. And this is my 0. This is my, was it a point we saw? Point, is it point, 0.16. Okay. So I have here the negative 0.16 and 0.16. So notice that by symmetry I just need this area and I want to double it. So I go to the z table. I need go to z.1. My second decimal is 0.6. 0.6. So I go there and find that value there and double that value, and that gives me 0.1272. If I use the binomial p of x equal 20, I have repeated the experiment 40 times. I want 20 successes. Probability of success 20 raised to power 20. Probability of failure, so 0.5. 1 minus 0.5 is 0.5 raised to power 20, because that's 40 minus 20, 20. And I do these calculations. It's going to be 0.1268, and you can see the answer here and there are very close. So the normal approximation works very, very well. And the same thing for the second question. So if I want p of x between 10 and 20, now how do I know if I should subtract or add? And this is what I'm going to show you next. So x should be between, so I go here 1 point to the left here, 1 point to the right, and then I find the z-scores and complete this problem. And the way you figure that out is this. Oops, so I want here is my 9, 10, 11, and here somewhere here I have 19, 20, 21, and you notice that I want the area, the probability is between 10 and 20. Okay, so basically I'm gonna go half a point here, and I go on this side half a point there, because I want to cover these two probabilities here, and that's how I figure it out. And once we get that, so we get the z-scores and find that probability. And thank you. Next talk I'm going to talk about the uniform and the exponential distributions.